All right, Algebra crew, we are doing our next section, all right, 10.3, which is operations with radical expressions. Hopefully everybody had a great Easter, and we're in the home stretch now, all right, last month of school, so let's finish strong, okay? I'm going to do the first 6 problems from your lesson check, and hopefully everybody read the section. All right, and we need to and looked at the notes that I posted. So just like when we have like terms, all right, like 4x plus 5x is equal to 9x. All right, we have like radicals. You can only add radicals together if they have the same number underneath the radical. Okay, so that's what we're going to be focusing on. And there's a couple other rules that you need to look at, but I'll cover those with these 6 problems. So number one's a pretty simple problem. It's just 4 root 3 plus root 3. So 4 root 3 plus root 3, those are considered like radicals. And all you're doing is adding these together. You add the numbers in the front of the radical together. So 4 root 3 plus root 3, and this root 3 is actually 1 root 3. So this answer would be 5 square root of 3, because it's 4 plus the understood invisible 1 right there. So 4 plus 1 is 5 root 3. So that was a pretty easy one. Number 2, we have 3 root 6 minus root 24. Well, these are not like terms, but we can get it to a like term by reducing this or simplifying this radical. All right? So if I do a little side work and I simplify the square root of 24, the square root of 24 can be written as the square root of 4 times the square root of 6. And what is the square root of 4? 2. So now I have this root 6 here and this root 6 over here. So I'm going to just take this and put it over here for the 24. So now I have 3 root 6 minus 2 root 6. That's after simplifying this. So 3 root 6 minus 2 root 6 is 1 root 6, or just root 6. So that would be your final answer, square root of 6. Let's look at number 3. Number 3 is a multiplication. So we have the square root of 7 times the square root of 3 minus 2. Remember, we need to distribute the square root of 7 to both terms inside of the parentheses. So we have square root of 7 times the square root of 3, which is the square root of 21, and then the square root of 7 times the square root of, square root of 7 times 2. We can't multiply those together, so you just have to leave it as 2 root 7. So our final answer is square root of 21 minus 2 root 7. Remember, when multiplying, you can only multiply numbers together that are underneath the radical. And if you have numbers that are outside and you're multiplying to a number inside, then you just write it like that, all right? So, number 4. Number 4 is the square root of 5 minus 6 squared. Well, I'm just going to rewrite this as the square root of 5 minus 6 times the square root of 5 minus 6. And we would FOIL it. Remember, first terms. So we have the square root of 5 times the square root of 5, which is the square root of 25. And then we have the square root of 5 times a negative 6 is a 6 root 5. And then negative 6 times square root of 5. and then negative 6 times negative 6. And remember, square root of 25 is just 5. And then we have a negative 6 root 5 minus 6 root 5 will give us a negative 12 root 5. And then we have plus 36. And then what is 5 plus 36? There you go. 41 minus 12 root 5. All right, let's look at number 5. Number 5, we need to use something called the conjugate. And they define a conjugate at the top of page 628. All right? And the reason that conjugates work is because of those special, the special cases when we were multiplying our binomials, okay? And so in the denominator here, we have 3 plus the square root of 2. Well, remember, the problem is we can't have a square root in the denominator. In order to get rid of that, you multiply the numerator and the denominator by the conjugate. Basically, it's the same numbers, but you change the sign. Instead of a plus, I'm using a minus. Because what happens here, if we were to FOIL this, 3 times 3 is 9. And then you do 3 times a negative square root of 2, you get negative 3 root 2. And then we have square root of 2 times 3, which is a positive 3 root 2. And then square root of 2 times the square root of 2 is the square root of 4, or just 2. Okay? These cancel, right? So all that we're left with is 9 minus 2, which is 7. So, after multiplying or FOILing the denominator, I get 9 minus 2, which is 7. And then in the numerator, I have 7 root 5 times 3, which is 21 root 5. And then 7 root 5 times root 2, which is 7 root 10. All right? And I can pull a 7 out of this numerator, right? So if I pull a 7 out of the numerator, I have 3 root 5, because 21 divided by 7 is 3. And I take the 7 out of here, so I'm just left with a root 10. All over 7, these cancel. So my final answer is 3 root 5 minus root 10. All right, number 6. Number 6 is another conjugate problem. We have a 6 in the numerator, and then in the denominator we have square root of 7 plus 2. So I need to multiply both the numerator and the denominator by this, square root of 7 minus 2. And I already showed you what happens to the middle two terms after you FOIL. They cancel. The same thing will happen here. So you don't even need to show it anymore. All you need to do is multiply square root of 7 times the square root of 7, which is just 7. And then 2 times 2 is 4. So we have 7 minus 4 in the denominator. In the numerator, we have 6 root 7 minus 12. So we have 6 root 7 minus 12 all over 3. And I can factor a 6 out of this numerator, right? So if I factor 6 out, I have root 7 minus 2, right? And the 3 will cancel. So my final answer is 2 root 7 minus 4, because the 2 times the 2. All right, so hopefully that helped you. The conjugate problems can get a little weird, but if you just follow the steps, all right, it will be okay. So hopefully that helps. Hopefully everybody's staying healthy, and hopefully I get to see you soon.